We are very lucky to have Alberto Cairo. You probably know him already, but I will say a few words about him. He's a journalist, maybe a data journalist, but not only a data journalist. I think he's a journalist and designer. He holds the night chair in visual journalism at the University of Miami, where he is also director of visualization in the Institute for Data Science and Computing. This is the official biography of Alberto. Maybe why he's really famous is for this kind of thing, the Functional Art book in 2012, I think, translated in 5 languages. There is also another book that is at my office, The Truthful Art. That's also a big success. And this very recent one, this one, How Charts Lie, Getting Smarter About Visualization, is a bestseller. The new version actually has a yellow cover and an afterword with COVID-19 update. So this is probably why he's very famous, and this is well deserved. These books are fantastic, especially for teaching, but not only. And this is probably why you are here today. But for me, as for many, I think Alberto Cairo is most of all, a tireless advocate of visual literacy. We know how visual literacy is something that is not known or studied, and Alberto Cairo, with his book and his teaching, is really helping raising the level of the visual literacy in the whole world, actually. He devotes his energy to fight misinformation, including political falsehood, which is something very brave to do and essential to our democracy. He promotes, teach, and disseminate good practices in information visualization. He belongs with few others to the family of preachers who believe that we can make a better world with a better information. That is, an information that can reflect the complexity of this world without being messy or simplistic. An information that is designed not to be beautiful, but to make its contents understandable by anybody. And this is really a beautiful idea. So without further ado, because his word is precious, I want to spare time for him. So without further ado, but with my sincere gratitude for all what he has done so far, and including being with us today, Alberto, the floor is yours.
All right, it seems that we are going to begin early. So I would like to begin by thanking you, Christophe, because I mean, I really appreciate your words. I'm always amazed that books written by a journalist like myself ended up being enjoyed by statisticians and data scientists. That's a huge honor for someone like me who doesn't have a formal background in statistics or quantitative thinking. So I really, really thank you for that. It's a huge honor again. And I would like to thank you all for being here today. I'm going to talk about data visualization, obviously. I am going to begin in just 1 minute. But again, before we begin, I also would like to thank Banco de Portugal for inviting me. Muito obrigado. I'm not speaking Portuguese. Muito obrigado por me convidar. Vai ser prazer fazer esta apresentação. Eu acho que vai, o povo vai curtir. And now I switch back to English. Anyway, so I am going to share my screen in just 1 minute. Before I get started, a little bit of housekeeping. The organizers, right after I finish presenting today, during the quick Q&A, we will have a Q&A at the very end, as Christophe was mentioning. We'll share my slides with all of you. So a PDF version of my slides will be shared with everyone. The reason why I do this is that, as Christophe said, I'm a great believer in democratizing data visualization. I think that data visualization is a skill that anybody can learn and can benefit from. So my presentation essentially gives you a few tips of how to design better data visualizations. And it also includes links to resources that you can use later on if this talk gets you excited about data visualization. So I'm going to begin sharing my screen. You should be seeing my screen right now. Perfect. Christophe is telling me, giving me the thumbs up. I really appreciate that. So how to make decisions in data visualization? Well, I'd like to begin by talking a little bit about my work at the University of Miami. I am a professor, as you know, but before I became a professor, I was a practitioner of data visualization. I still am. I still produce data visualizations for hire as a freelancer. One of the jobs that I have at the University of Miami, besides being a professor, is to be one of the members of an institute that we have called the Institute for Data Science and Computing. And when they invited me, I said, well, I'm not really a data scientist, so what am I going to do here? And people who work at the institute said, well, of course you are a data scientist. I mean, you work with science, you help translate the science, you help to communicate the science, and you use data visualization to communicate that science. So that's part of data science. I said, okay, I guess that I'm in part of data science, scientist in some sense, right? And a few years later, I stumbled upon a very funny cartoon about how data science is perceived from the outside and how it is perceived from the inside. So the first part of the cartoon is a pie chart that is complete, has just one segment of how people from the outside perceive the work of data science. And the work of data science from the outside is often perceived as being made of just machine learning models, creating fancy models and forecasts and predictions and work with big data, all very fancy, all very complicated. But when you are inside the world of data science and you practice it and you work it, you know that the reality is closer to this pie chart, that a huge portion of the time and the effort is spent identifying the right problems and defining them, then gathering the data, organizing the data, cleaning up the data. That's a huge portion of the pie, getting the data ready to be analyzed. And then there are two segments of this pie chart that are the ones that I'm more interested in because they are the areas that I work on, which are these two. So there's a part of the pie chart that is exploratory data analysis, which is identifying patterns and trends in data that may be promising for future research or for future inquiry. And then there is the communication part. Once you know what the results are of your exploration, you will want to communicate them either to people within your organization or to the general public. And that's where I come in. That's what my work is about. So data visualization has a dual nature, right? We are right now going through a second golden age of data visualization. The first golden age of data visualization was in the 19th century with the work of pioneers such as Florence Nightingale, the famous nurse in the UK, or Dr. John Snow, also from the UK, William Playfair, and many other pioneers in the 19th century. But the second golden age of data visualization that we are living in today, we are still in that golden age, began with the work of several statisticians. The most important one, I believe, is John Tukey, who back in the 70s published this very famous book, Exploratory Data Analysis, which is widely considered one of the landmarks in the history of data visualization, mainly for exploration, for the exploratory analysis, but also for communication, because the tools that were created to analyze data can also be used to communicate the results of those explorations. And what Tukey pointed out in this book is that the greatest value of an image is that it forces you to see things that you didn't notice before. That is what visualization is about. It's about detecting patterns and trends in data that may go unnoticed if you don't visualize them. In the book, he says, whenever you're exploring data and analyzing data, always visualize your data. Because if you don't visualize your data, there may be features in your data that you may not perceive if you don't transform your data into a picture. Now, data visualization is everywhere nowadays. It has been adopted by worlds such as, disciplines such as business analytics, for example, by scientists from all stripes. As part of my work at the university, I partner up and collaborate with scientists from tons of disciplines: climate science, environmental science, biology, physics, mathematics, statistics, and all of them use data visualization in one way or another, not only to explore data, but also to communicate results, to make beautiful, nice looking, clear and deep graphics to communicate the results of that science to the public. In the world where I come from, the world of journalism, there has been an explosion in the use of data visualization in the past 10 years. Data visualization has even appeared in the cover of the most widely read magazines and newspapers all over the world. Data visualization is becoming iconic in some cases, such as in the famous warming stripes graphics by Ed Hawkins, which appeared on the cover of The Economist magazine. It has appeared in protests and demonstrations. It has been printed out and pasted on cars, so people drive around with this data visualization. In case that you have never seen it, what this data visualization shows is the average temperature of the world from 1850 up to 2016, I believe, using shades of color to represent the data, right? Light blue represents lower temperatures and red represents higher temperatures. And the redder the color, the deeper the red color becomes, the higher the average temperature is. This is called a heat map, this type of visualization. Now, why is data visualization becoming so popular in the world of journalism in this case? Well, it is in part because media organizations, particularly in the US but also in Spain and the UK, the countries that I am most familiar with, are seeing through their analytics that readers love visualization. Once you put a nice, well-designed, deep and informative data visualization in a story, engagement with that story increases greatly. Not only that, many of the most popular stories ever published by media organizations in the United States are data visualizations. The most popular story ever in the history of the Washington Post online is a data visualization related to COVID-19. They created this story that I link here. Remember that we will share the slides later so you can see all these examples, which basically represents what happens in a country if a country adopts measures against a pandemic or doesn't adopt measures against a pandemic. Each one of those circles represents a person, and as you can see, they are passing the disease to each other. This will be a country that doesn't adopt measures, so the disease spreads very, very, very quickly. This is based on a mathematical model, obviously. But then if a country adopts measures such as social distancing, things like that, then the spread of the disease becomes much slower. The story contains many other animations, many other data visualizations, many other graphics. The most popular story ever published by the Washington Post online. For many years, also the most popular story published by the New York Times, which is the other big national newspaper in the US, was also a data visualization. I didn't put it in the presentation, but in case that you want to find it, it's commonly called the dialect map, the map of the dialects of English in the United States. And it's the most popular piece of content in the New York Times. The Washington Post, going back to the Washington Post, by the way, this is sort of like an anecdote, but it's a very illustrative one. This same year disclosed that out of the 7 most popular stories that they have ever published in their history, in the history of the Washington Post online, out of the 7, 6 of them were stories produced by the visualization department at the Washington Post. 6 out of 7. So this tells us something about how much readers appreciate graphical presentation of data, graphical presentation of information. It also shows you how popular it can become, how persuasive it can be in many cases, and how perhaps we should all think about adopting data visualization as part of our toolkit, because it will make us better communicators. If we can speak correctly and great, that's fantastic. If we can write, if we can do great writing, that's great. But then if we increase our toolkit to include data visualization, we will be better rounded better communicators in some sense. So that's what I try to teach in my own classes at the University of Miami, where I teach my students how to create data visualization for communication. This is just an example of a poster designed by a former student of mine who's now working in the world of data journalism, which illustrates this idea that I always like to repeat in my classes. First of all, data visualization is not magic. Anybody can learn, right? As long as you know how to use a few tools, and many of them nowadays are pretty easy to learn. You mentioned at the very beginning, Anna mentioned Power BI. You also have Tableau, you have Data Wrapper. If you like coding, there are great coding solutions such as the R programming language, which I use. There are so many options nowadays. And these options, these software options that are in many cases free, sometimes they are open source and they are very accessible in comparison to tools that we had 20 years ago when I began my career, also in part of explain this explosion in data visualization. In any case, I teach my students how to use many of those tools. I also teach my students how to structure visual stories, how to convey information through the combination of words and visuals. And this is a skill that anybody can learn. And my goal today is to give you a few tips on how to move towards this goal, how to use data visualization for communication. A part of my philosophy of teaching is to say that whenever a newcomer enters the world of data visualization, if that newcomer reads older books from the 70s and the 80s, these books are written as if they were providing a set of rules of data visualization, right? Do this, don't do that. Pie charts are bad, use bar graphs. All that is not true, and I will explain to you why I think that is the case. So I changed my philosophy of teaching and my philosophy of learning of data visualization to never talk about rules that are set in stone, but to talk about choices and justified, reasonable, and recent choices. This will be the topic of my next book after How Chats Lie, the one that I'm supposed to be writing right now and publishing in 2022. How to make choices, how to reason about data visualization to make justified choices. Because beyond certain conventions and certain constraints that are based on how the human visual system works, there are really not rules that are set in stone in data visualization. We have principles that are flexible, that have many exceptions, that are dependent on many factors. So I believe that to learn data visualization, what we need to think about is not in terms of rules, but in terms about reasons. Let's give myself and let's give other reasons for the choices that I'm making to design this particular data visualization. And I usually structure these reasons in terms of posing questions whenever we are designing data visualizations. So I'm going to structure the presentation also according to a few of these questions, not all the questions, but just a few of these questions. The first question is, why should the visualization exist in the first place? Do I really need a visualization? Because in many cases, we don't need a data visualization. In many cases, we need just a simple table. It all depends on what we want to communicate, right? This is a table. It's a table of global temperatures. It's actually one of the tables behind the heat map that I showed you before of global temperatures in the world, right? So this is a table that contains the average global temperature in the world measured in Celsius degrees from the year 1000 up to the year 2000 or 2005, right? You will see negative values. Well, there's obviously not a negative average temperature. The reason we have negative values here is that the baseline of this data set is the average temperature in the middle of the 20th century. So the negative value means below that average and positive temperatures means above that average, right? In any case, this is a very famous data set. It was published in the late 90s. When should we present a data set as a table and when should we present the data set as a data visualization? Both of those options are good, depending on what we want to achieve, right? Now, what are tables useful for? Tables are useful and should be used when our purpose, when designing a graphic, and a table is a type of graphic, when the purpose of the graphic is to let the reader identify individual values and locate them very easily. So if I want to see what the temperatures was in 1867, I can just go to the rows, then go to the column and just crisscross one with another and locate that specific value. But when we do analysis and when we want to communicate ideas to other people, what we care about is not every individual value. We care more about the big picture of the data and the big patterns and the big trends in the data. And those are much harder to spot when we present the data as a table, right? When we care about the big picture, a visualization may be much more appropriate because answering certain questions with a table may be actually quite difficult. For instance, did the global temperature increase or decrease in the past 1,000 years? Well, we all know the answer to that. it increased. But if we didn't know the answer to that question, answering that question only through the table may be a little bit difficult, right? It may be easier to do that if we transform all these numbers into a graphic. So this data set is behind one of the most famous and also influential, I think, and also persuasive data visualizations published in the 20th century, which is usually named the hockey stick chart, because it creates the shape of a hockey stick, right, that is put on the floor. What the graphic conveys is the idea that between the year 1000 up to the year 1900, 1920, global temperatures vary, but they varied within a certain range. But at the beginning of the 20th century, the pattern changes, and we see a very rapid increase in these global temperatures. This is the pattern that was not possible to see if we presented the data in a tabular format. It only becomes visible, as Tukey said in his book, Exploratory Data Analysis. The picture forces us to see something that we didn't see before. Now, the chart contains a lot of other data that I'm not going to describe. It also contains the uncertainty of the data. It contains a trend line, that's the smooth of the data, right? If you work in the statistics, you will be able to identify all these features. This is one of the charts that I describe, by the way, in detail in one of my books. But the point is that to show the pattern, to show the trend. So when the big picture and the patterns and the trends are more important than the individual values, and our purpose is to highlight those patterns and those trends, that's where data visualization comes in. If we care about the individual values, then a table is much more appropriate than a data visualization. And that will help us answer the question, do I need a data visualization? Well, in this case, probably yes. That doesn't mean that we should not provide a table as well, but the table should be secondary in comparison to the data visualization, because our priority is to show the patterns and trends in the data. The other question is what to visualize. And this is related to the question, do I really understand what it is that I'm visualizing? And the reason why I say this is that this is probably something that doesn't ail you all as much as it ails journalists and graphic designers. People sometimes are distracted and they don't pay attention to the definitions of the metrics or the measures or the variables that are being presented to them. And they jump to conclusions very, very quickly. But this discussion will have a coda that will be also useful for you all, for statisticians and data scientists. This is what I mean. I'm going to illustrate this with an example. Many years ago, one of my former students, Luis Melgar, who is now a visualization designer at the Wall Street Journal, he was working on his capstone project, and he wanted to do a project about homelessness in Florida, people who don't have a home in Florida. And he wanted to do an analysis and a written story and visualizations about how homelessness affects students. How many students in Florida are homeless? So he collected the data with the help of several experts. He got data from the government, from the Florida government, and he came to my office one day with several graphics, charts, and maps that completely shocked me. These are two of the maps, right? As you can see, these are all the counties in Florida. I live down here, by the way, on this tip over here. So this map reveals that there are certain counties in Florida where more than 5,000 students are homeless. And when we take a look at the percentages, there are certain counties in Florida in which more than 20% of the students are homeless. So, wow, this is a humanitarian crisis. 20% of the students are homeless. And he said, well, but we need to be careful here because I have not explained to you yet what it is that the state of Florida calls a homeless person. I was jumping to conclusions because by using the word homeless, the image that appeared in my brain was someone who lives on the streets under a bridge or something like that, right? That's the image that immediately popped to my brain. But that is not what the state of Florida calls a homeless person. A homeless person to the state of Florida is someone who doesn't have a permanent home. This means that, for instance, if a student, for instance, comes from a poor family and this family cannot maintain the same home all year round, but they need to change homes, for example, 3 times a year. Or if a student, I don't know, her parents are divorced and this student needs to live 3 months with her mom, 3 months with her dad, 3 months with an uncle, something like that. The fact that that student is changing homes several times a year may make that student be considered a homeless person by the state of Florida, because that student has a home. It's only that it's a different home depending on what part of the year we are, and that student may be considered a homeless person. So why is this discussion important? First of all, because if we are readers of graphics, as you know already, my latest book is titled How Charts Lie, and it's not really a book about how charts lie. It's a book about how to become better readers of charts, right? My first advice is pay attention, read the fine print in order to understand what it is exactly that graphic is showing. But the other side of the coin is that if you are a visualization designer, it is essential to include the explanation, the definition of the variable, not in the documentation of the graphic, but in the graphic itself, including the definition, for example, in this case, homeless people, and then including the footnote of what a homeless person is to the state of Florida in the graphic itself. The state of Florida calls a homeless person someone who doesn't have a permanent home, but that doesn't mean that this person lives on the streets, right? That's a piece of writing that needs to be in the graphic itself. Later on, I will circle back to this idea, because the words that we put in a visualization are as important or more than the visualization itself. We call these the annotation layer, the annotation layer. Unfortunately, when we design visualizations, we sometimes just put the word, for instance, homeless, and we expect people to understand or to click on the documentation link in order to understand what the word homeless means in this particular context. Most people don't do that. So if something is essential to understanding a visualization, it needs to be in the visualization itself. The other question is how much to visualize. This is also a huge problem in the worlds that I come from, the world of journalism, the world of visual design, because in the world of journalism and communication in general, we tend to say that our work consists of simplifying things. And I really dislike the verb to simplify. I prefer to talk about the verb to clarify, which is completely different. This is not something that I came up with. It's an idea that I borrowed from my friend Nigel Holmes, who's a very famous visualization designer. Anyway, so what is the difference between simplifying and clarifying? Let's illustrate that with an example. This graphic is the murder rate in the United States from the year 1960 up to the year 2015. We could extend this up to the present. The story that it says is that the murder rate increased in the 70s, came down during the 90s, stayed more or less the same in the 2000s. And then in the last 2 or 3 years, actually 5 years, 5 or 6 years, the murder rate in the United States is increasing again. It's increasing quite not very rapidly, but it's increasing. If we could extend this line, the line continues increasing. Now, there is nothing wrong mathematically and geometrically speaking with this graphic. It's completely right. It's the murder rate per 100,000 people. The scales are completely correct, but it's extremely misleading. Why is it misleading? Because most people don't have enough knowledge of this data in order to interpret this graphic correctly. And it is very easy to describe the content of this chart as the United States is becoming a more dangerous country since 2014. That is not true. Why is it not true? Because the distribution of the data behind this national rate is extremely skewed. Statisticians who work with crime data, they will tell you that most places in the United States, if we could plot them on the vertical scale, they will be a little bit above the national rate, a little bit below the national rate, but most of them are actually below the national rate, around here. This is all fictional dots that I plotted to illustrate. If we could plot every single place in the United States, most of them would be out there. Now, what is the problem here? The problem is extreme values, right? Other name, outliers. The challenge is that there are certain cities and neighborhoods in those cities in the United States, and towns also, and places, different places, but not many, in the United States that have become so dangerous in the past 5 or 6 years that they sort of like skew the national rate a bit. They move it up. If we could remove them from the mix, then the national rate will stay more or less the same, but they skew this national rate. So this illustrates the problem, I think, with using highly aggregated metrics such as a national rate or, measures of central tendencies such as the mean, right? In cases when we have a distribution that has a huge range and it also is extremely skewed. This is an example that I usually use when explaining these ideas to journalists, but I think that they can also be helpful for statisticians, because statisticians also tend to present highly aggregated data. And this is correct in many cases. For instance, if most places in the United States had a rate that is similar to the national rate, or they are all around these places, then it will be okay to just show the national rate, just because the national rate is a good illustration of the entirety of the data set. But when we have a distribution that is so skewed, we could still present this data to the public this way, but then we need to explain these. We do need to explain these, because otherwise people would not be able to interpret the data. It would not be needed to visualize every single observation, obviously, but we could illustrate this perhaps by visualizing at least a few of these locations, just as an example of what an extreme value means in this particular context. This is the difference between clarification and simplification. This is a simplification. But when we add that explanation, or at least we increase the level of detail in the visualization of the data, when that detail is essential to understanding the story, then the visualization clarifies things rather than simplifying things. Later on, in the extra resources that I will show you at the end for you to read after the presentation, there is also a series of resources to visualize uncertainty. Because in the United States, and also in Spain and many other countries, when newspapers and magazines report, for example, the results of opinion polls or political polls, they often don't visualize the confidence intervals of those polls. And sometimes the difference between two candidates are very small, and the margin of error around those point estimates is extremely large, to the point that it should be visualized, because otherwise people will extract the wrong inferences from those graphics if the uncertainty is not displayed when the uncertainty is critical to understanding the message of a visualization. The next question is how to visualize it, right? This is related to the question, what types of graphics should I use? Should I use a bar graph? Should I use a line graph? Should I use a map? Should I use a pie chart, right? Sometimes people ask me, what is your favorite data visualization type? And say, well, I love scatter plots. I like scatter plots aesthetically, but that doesn't mean that I recommend that people use scatter plots for everything, right? That doesn't make any sense. The choice of a visualization type, of a type of what we call in visualization, a type of encoding, right, depends a lot on the type of message that we want to convey, on the type of audience that we are talking to, on the type of data that we are using, and moreover, or more importantly, the type of message that we want to convey to people. Take a look at this graphic. This is a graphic that shows among all the migrants, that's a pie chart, obviously. So we have a total of all the migrants who arrived to Greece in 2016, which percentage came from other countries, right? So we can see immediately that almost half of these migrants came from Syria, around 1/4 came from Afghanistan, and then the rest came from other countries, right? Now, if I were asked, and I was asked, do you think that this is a good graphic or a bad graphic? I would answer what I always answer. I don't know if it is good or bad if I don't know what your intentions were when you were designing the graphic. And I will pose the discussion this way. If the purpose of this graphic is to immediately show the reader that nearly half of these migrants came from Syria, and the other sort of half came from other countries, this graphic works. There's nothing wrong with it. That's why I usually say, the old book said, don't use pie charts, never use pie charts. Well, no, a pie chart may be appropriate if the message is simple, such as this one, half versus half, right? The only change that I would make to emphasize that message even further, and this is a design decision, and design is extremely important, will be to emphasize this even more by coloring Syria with one color, and then all the other countries, all of them, with a single color, just with a single color, because that will further emphasize Syria is much more relevant. We want to emphasize it more than all the other countries. However, let's suppose, just for the sake of argument, that the message that this chart is trying to convey is not half versus half. Let's suppose that the task that we want people to accomplish or to undertake with the visualization is not to see half versus half, it's to compare these countries to each other. We want to compare Pakistan to Iraq, Iraq to Syria, Algeria to Afghanistan, etc. Now, pie charts are not great for comparison. We know that. We have a lot of empirical evidence showing that. If you want to compare the relative size of all these segments, you need to squint and even use your fingers to sort of like estimate the relative sizes of all these segments. It's not that easy. So if the purpose is comparison, then perhaps a different type of visualization is better. Perhaps a bar graph or variations of the bar graph, the dot plot, the lollipop graph. There are many, many other graphics that we could use for comparison. And moreover, another possible scenario, let's suppose that the purpose of this graphic is neither to show half versus half, nor to compare things to each other. We want to see where these countries are. Well, then in that case, we need a map. And we can overlay perhaps a bubble chart or something to represent the percentages who came from different countries. So I quickly designed 3 different visualizations based on this very tiny data set to illustrate that we need to give ourselves reasons to shape the data in one way or another, depending on what the purpose of the visualization is. If we want to show parts of a whole and to emphasize, to stress half versus half, the pie chart may work. But if the purpose of the visualization is comparison, the pie chart is better. The bar graph is better. Even if you don't read these numbers, you will be able to immediately to compare all these bars to each other. The relative proportions, you will be much better at that than with the pie chart. And if you want to show geographic patterns, then a map will be better. Now, this is one of the examples that I usually use in my classes to begin the discussion on how to choose graphic forms. Because what I know is that most people who are beginners in data visualization tend to work in autopilot. And this is what I mean. I know for certain that if I teach a workshop of data visualization and I give my students, to be beginners, right? I give these beginners a data set in which everything adds up to 100%. I say, design a data visualization. And I don't talk about purpose. I know that most of them will come back to class with a pie chart. And then I ask the question, why? The question why is extremely important. Why is this a pie chart? What is the reason to design a pie chart? And the reason they usually provide is, but the data adds up to 100%. That's not a good reason. The good reason will be, well, I want to show half versus half. I want to show parts of a whole. But what if the purpose were different, right? Perhaps you need a bar graph instead of a pie chart. And then if I also know, another example, if I give students, beginners, a data set that contains geographic variables, such as countries or states or counties or whatever regions, I know that many of them will come back to class with a map. I say, well, why is this a map? Well, because there's a geographic variable. That's not a good reason to design a map, because perhaps the purpose of the visualization is not to show geographic patterns. That's what maps are for. Perhaps the purpose of the visualization is comparison, in which case many other visualizations may be more appropriate. So the first thing that you need to do if you want to become a visualization designer is never to work in autopilot and never rely too much into the defaults that software tools offer you, but to try to control the software tool and make the decisions for the software tool. There are many resources that you can use to make choices, by the way, in terms of choosing graphic forms. 2 of my favorites, and there are many, many others, are the Data Visualization Catalog, which is exactly what it says. It's a website that contains small articles, short articles about different visualization types, with discussions about when to use them, when not to use them, how to use them correctly, extremely informative, very, very useful. And then the Visual Vocabulary, which is a big poster that can be downloaded in high resolution online, designed by the visualization department at the Financial Times. This is a poster, by the way, if you ever had the opportunity to visit the newsroom, the headquarters of the Financial Times in London. If you walk around, you will see this poster framed and posted on the walls, because they use it in the newsroom to make choices, to make decisions in visualization. Say, well, we are working on this story, financial, changes in the UK, whatever, and we want to show change. Well, we want to show change. What types of visualization we could use? So let's try these ones, right? We have all these other options. It is a poster that organizes the main visualization types according to the main purpose that that visualization may help you fulfill or may help you pursue. You want to compare, you want to show change over time, you want to show the distribution, you want to show geographical patterns or geospatial patterns. There are different visualization types that you can use for one thing or for the other thing, always depending on purpose. What words to add? This is what I mentioned before, right? The annotation layer. So visualization is not just about for communication. I'm talking about visualization for communication, not for exploration. When we want to communicate with a visualization, the visualization alone on its own will usually not be enough. We need to pair it with a good title, with a good introduction, and with good annotations here and there that emphasize the main things or that put the data in context or that explain something to the reader and so on and so forth. And we call this in journalism the annotation layer. Most people who work in visualization in the world of communication will tell you that the annotation layer is extremely important. Some of them will tell you that is the most important thing that we do. So continuing with the Financial Times, one of their most popular data journalists, data visualization designers, John Byrne Murdoch, in an interview from a few years ago, he said that what they consider the most important in the data department at the Financial Times is not the visualizations. Obviously, the visualizations are extremely important, but what they consider most important is what they call that annotation layer that they put on top of the visualizations, pointing out the main features of the data, explaining a particular glitch in the data, highlighting or emphasizing a particular point, or simply putting the data in context, or explaining, as I mentioned before, with the homeless example, the definitions of the variables that are being presented in order to avoid possible misunderstandings of the data. That is all what the annotation layer can achieve. Now, the annotation layer doesn't always need to be written. Sometimes it can be spoken. So now I'm going to talk about one of the people who I believe are most fundamental to the history of data visualization for communication, Professor Hans Rusling from Sweden, who sadly passed a few years ago. Before that, he published a book titled Factfulness. If you are not familiar with Rusling's work, I would encourage you to visit his website, gapminder.org, and take a look at some of the presentations that he gave throughout the years. Because in my opinion, Rusling was one of the most successful and most efficient and funny and fun data presenters of all time. He was able to make data sing and to make data look meaningful and interesting to people who don't care that much about data. Now, let me show you just a quick snippet of video from one of his presentations. This comes from a documentary that he made for the BBC titled "The Joy of Stats." In this scene of the documentary, Rusling appears on the scene and said, "Let me talk to you about the world. But before I show you anything, be aware there is going to be a vertical axis, and countries will appear on this vertical axis. The vertical position is lifespan. Then there's going to be a horizontal axis, and the position of the dots that will appear on the horizontal axis means income levels of all these countries. So this means that if you are down here, your country is on average poor and sick. If you are up here, it means that your country on average is rich and healthy. And now let's show the world, right? So tons of dots will appear, and they will appear as they were in 1810. So I'm going to make the dots appear. The colors represent the continent that each one of these countries belong to. So blue is Europe, red is Asia, and then the size of the bubble is proportional to the population of that country in that particular year. So as you can see, most countries are down here. That means that life expectancy is really low. Income levels are also quite low. The highest life expectancies were in countries like the UK and the Netherlands. That was around 40 years old, etc., etc. So lifespans were not very high. But now, if we start moving towards the present, you will see that these dots will start moving closer and closer to the upper right corner, meaning that lifespans are increasing and income levels are also increasing. Now, throughout this video, he also points out specific cases. He stops the animation, highlights China, highlights the UK, highlights Sweden. At the end of the presentation, he gets the bubble from China, and it splits up the bubble from China to show different regions of China and the differences between different regions in China in terms of life expectancy and income levels. Now, I think that is a great example of how to present data effectively, but notice what he did before he began showing any data. before he showed any data, he explained to viewers how to read the graphic. This is a vertical axis. This is a horizontal axis. Color represents continent. Bubble size or bubble area represents a population. He was explaining to readers what we call, or viewers in this case, what we call in visualization, the encodings: color, position, area, size. Those are the encodings, which are the properties of objects that vary in proportion to the data or in relationship to the data that we are trying to represent. Now, why did he do that? Well, I never had the opportunity to talk to him and ask him about this particular case, but I can make an informed guess. He knew, or he had the hunch, that this was going to show in the BBC, right? People from different cultural, educational backgrounds will see this documentary. And very wisely, I think he thought, well, many of these people probably had never seen a scatter plot before, or many of them forgot how to read a scatter plot. So before I show any data, let me explain how to read a scatter plot. Now, this is extraordinary, I think, because it helps you it helped him not only display the data effectively, he was also increasing the visual literacy of viewers, because the next time a viewer sees a scatter plot, they will not need the explanation anymore. They will be able to interpret the scatter plot readily and fast. This was absolutely wonderful. Well, this is also the annotation layer. Sometimes when we use visualization forms that we think may be a little bit complex to general readers, we should not refrain from using them if we believe that is the most effective way to represent the data. We should not refrain from using them. What we should use is to include an explanation of how to read the graphic. It could be textual or it could be verbal, like in this particular case. And last question of the presentation. What about design? What about visual design? I know that the audience today here is mostly statisticians, data scientists. When I present these ideas to people like you, I tend to emphasize design quite a lot, because throughout my career, I found that people who come from backgrounds in science and from STEM fields tend to think that visual design is an afterthought, that making things look good is an afterthought. All right, my goal is to present the data as clearly as possible. And that's a worthy goal. That's a noble goal that I share. I think that we should prioritize showing the data as clearly and as effectively as possible. But caring about typography, color, composition, white space, margins, alignment, that is essential also, because it is the equivalent of writing correctly. When we write, we don't just write. We write and then we edit, we correct, right? To make our style sound better, to flow better, right? Design is quite similar to that. We should strive to make our graphics elegant and presentable to the public. This is something that I put a lot of emphasis in my classes, that caring about design is not an afterthought. It's an intrinsic part of designing a good visualization. And I usually make the joke, don't trust software defaults, because software defaults are usually evil and we should avoid them. It shouldn't be the software who makes decisions for you in terms of which colors to use, how dark the grid line should be, how to arrange the text in your visualization. It should be you who makes all these decisions. Take a look at this graphic. This graphic is about fisheries, if I remember well. The topic doesn't really matter that much. It's a stacked bar graph, which is sort of like a variation of a pie chart, right? It shows you the total and then the portions of that total, right? Different countries and so on and so forth, France, Italy, Spain, the UK, and then the different proportions. One thing, by the way, this is just an aside. One joke that I make to my students, it's only half a joke. This is actually true. I say, when you design anything, as a professor, I don't want to be able to tell which software tool you use to design this. When I am able to tell which software tool you use to design your graphics, that tells me that it was the software who designed the graphic, not a person who designed a graphic. I want to talk to people, not to computers. I want to get the sense that the designer put effort to make the visualization hers or his, right? And try to work on the style of the graphic. And this was done in Excel, as far as I can tell, earlier versions of Excel. In any case, there are many challenges with this graphic, right? There are many features in this graphic that don't really make your graphic more beautiful and don't make the graphic clearer. For example, the 3D effect, right? As you can see, there's a 3D effect here, and then the graphic is supposed to be projected on the background. That's absurd, because it's hard to tell, for instance, how big this red portion is. Is this red portion 82? Oh no, it seems that I need to project it. It may be 85 or 90. It is difficult to tell, right? 3D effects in static visualizations are extremely, extremely, extremely dangerous, and we should avoid them. The grid lines. I am a fan of grid lines. I try to keep grid lines in my graphics, because I think that grid lines help people sort of like estimate proportions, but I downplay them. I make them really light, almost invisible, very, very thin. And these ones are a little bit too thick. So I will make them thinner. And then this text over here, this looks ugly. Right? It doesn't look elegant, it looks clunky. But notice that in every one of these labels, we have two elements. We have one element and then another element. We have the label and then some sort of clarification in between parentheses. Those are two different elements. So wouldn't it make more sense to put the two elements in two different lines? Each one of these lines is going to have two lines anyway. So why don't we put the label on one line and the clarification on another line? The label on one line and the clarification on another line, and then play with the style of this text to emphasize the difference between the legend and then the clarification, the legend and the clarification. So how about that? This graphic, just with tiny design changes, already looks a little bit clearer and a little bit organized, a little bit more pleasant to the eyes. Take a look at the text, for example. Doesn't it look a little bit better organized? This is what I mean by design. Visual design is not about making things prettier, although that is one of the byproducts of good design. It's about making things clearer and better organized. When we make things clearer, better organized, having a better hierarchy, visual hierarchy, as a byproduct of all that, the elegance of our graphics will increase greatly. Now, what is the challenge? That we need to put time on these. We need to put time on making all these edits. But what I usually say to students who come from a background in writing or in science, I say, well, if you put a lot of attention to the writing in your research paper, right, you should put the same amount of attention on your designs. The same amount of editing that you do in your writing, the same amount of editing that you should do in your designs to make your graphics a little bit more presentable. I sometimes illustrate all these ideas with bigger designs, with research posters, for example. Right? This is a research poster that was designed by students at the University of Miami. Not a bad design, but certainly a design that could be improved. I actually used it in one workshop that I gave to science students at the university to try to help them design better looking research posters. So as you can see, the poster looks nice, it has 3 columns, but I pointed out it looks a little bit too text heavy, right? We have so much text over here, it looks very clunky, it looks very cluttered, but I'm going to show you. With the first thing, and if you agree, your first impulse will be to reduce the amount of information, to start cutting text here and there, to reduce things, etc. Don't do that. First of all, think about the design itself. And if you can preserve the same amount of content without reducing it, just by changing the design of the poster, then keep the same amount of content. Depth is extremely important in data visualization. So I pointed out several things that I would change. For example, getting rid of these background boxes that are not really necessary. I made the same joke I made before about this diagram here. I said this was designed in PowerPoint, wasn't it? Right? It doesn't look that great. Let's make it look better. I also talked about this scale over here, this scale on this map. This scale is what happens when you let the software make decisions for you. This is the incidence of malaria in the Amazon region per 100,000 people. And take a look at how many tick marks that scale has. I said, this is completely absurd because the purpose of this map is not to let you identify every single color. The human brain cannot do that, right? The purpose of a map like that is to give you the big picture. So the scale could be simply something like maximum value, minimum value, median value, and then you may want to add the quartiles or something like that. And those are the only things that you need on the scale. You don't need this level of detail, but that will force you to make the software do what you want to do, not what the software wants you to do. And then my favorite part that I made a lot of fun of, in a good way, I never make fun of the students. I usually say, everything that I'm pointing out here is something that I have done myself. So I know where all these problems come from because I was in the same place where you are. Take a look at this bar chart over here. Why is this bar chart so enormous? It doesn't need to be that big. It's only 2 values, right? Why is it so enormous? I can tell you why it is so enormous, and I made a guess, an informed guess. It was probably because you were designing your poster, and at the end you had a huge hole, right? And you didn't know how to fill it up. And what you did, you scale up the bar graph enormously to make it fit in that space, right? The size of an object should be proportional to its importance, but also to the amount of detail that it contains. And this bar graph doesn't have a lot of details, just two values. It even has a legend. That's also absurd. Why do we need a legend when we only have two objects? It's much better to transform the legend into labels, right? The rule about legends, by the way, is that legends are only necessary when they are necessary. Like in this map, we do need a legend because we cannot label every single variable. But here we can. We can put the labels down in the bar graph. In any case, I could go on and on here. I transformed that poster into this poster, which keeps exactly the same amount of information, exactly the same amount of data, but it looks a little bit lighter because it increases the amount of white space, the margins, white space alignment, visual hierarchy. It also improves the visual hierarchy of the project in terms of changing, for example, the style of titles to make them stand out, the size and the color of subtitles to create a visual hierarchy according to the different types of text. This is what I mean by design. It's not about making things prettier, although that is a byproduct. It's about organizing your information a little bit better. And design can be learned. Some of the resources that I will give you at the end will help you learn a little bit more about the importance of visual design. And finally, how creative should I be with my visualizations? My own style of visualization is very similar to, for instance, the New York Times style. These are graphics by the New York Times, by very recent graphics. My own style of visualization is similar to these. I tend to stick to traditional visualization forms, the bar graph, the line chart, the choropleth map, and so on and so forth. And I tend to create graphics that are very bare, right? Straight to the data, straight to the information, and that's it. Not very creative. But there are people who are very creative in visualization. So let me talk to you, just to finish the presentation, about the work of my friend Jaime Serra. So Jaime is also a visualization designer. He worked in visualization for many years for newspapers and magazines. He's perfectly capable of designing visualizations like these, as I am. But Jaime also has a side career as an artist. He creates art based on data. One day, he wanted to visualize how much coffee he drinks throughout a year. Now, if I had to do that myself, the way that I will do it will be to, for instance, get the cup that I use every day to drink my morning coffee, draw some sort of a scale on the cup, and then every day when I pour the coffee in, I will measure the number of milliliters of coffee that I'm drinking. I will record that in an Excel spreadsheet. I will bring it into a visualization program, and I will design a line chart to see whether there is some seasonality in the data, some interesting variations in my coffee consumption patterns, right? Not very creative, but extremely effective. Why is that? Well, because I tend to think of visualization as something that is more analytical, more intended to display patterns and trends. I will just stick to traditional, well-tested graphic forms. But the purpose of the graphic that Jaime wanted to design was not analytical. He wanted to design something a little bit more artistically expressive. So here's what he did. When he was going to drink coffee, he poured coffee in his cup, and he made a little bit of the coffee to spill in a way that the coffee accumulated at the bottom of the cup, of the coffee cup. And then what he did was to get 12 pieces of paper, 12 very large pieces of paper, and he folded those pieces of paper horizontally and vertically in order to subdivide them into quadrants. 12 pieces of paper, 1 piece of paper per month. He was essentially designing a calendar. And then every day when he was drinking coffee, he put the cup of coffee on top of the corresponding quadrant, to the quadrant that corresponded to that day, in order to leave a coffee stain on the paper. And at the end of the year, what he had was a physical visualization of coffee drinking patterns, right? January, February, March, April, May. For some reason, in May, he was drinking a lot of coffee, probably very stressed out and working a lot. December, probably on vacation. I don't know. We have long vacations in Spain. I don't know if he was on vacation. I'm making this up. But my point is that even if the purpose of the this visualization is not analytical, is not precision, is more artistic, we can still see patterns in the data. Now, you may be thinking, why are you showing this visualization? I am a statistician. I'm a data scientist. I just want to show the data. I would say, yes, 99.9% of the time, we want to stick to these types of visualizations. But 1% of the time or 0.1% of the time, right, we may want to think about something a little bit more unique, a little bit more customized, such as these. In which circumstances? This also comes down to purpose. We can give ourselves reasons to design something like that in complement or instead something like that. Imagine, just for the sake of argument, that you're writing a report about coffee consumption in the Bank of Portugal, right? Of all the workers in the Bank of Portugal, whatever. And you collect data all year round and you measure, how much coffee every person drinks. Then you slice and dice the data according to gender, to race, to region where that person works, and time also, time patterns, time series patterns, etc. of coffee consumption. And you write the report and you publish the report as a book, for example. What do you put inside of the report, in the inside pages? You put visualizations such as these ones, right? Because these visualizations are analytical. They let you see patterns in the data, changes, comparisons, and so on and so forth. What do you put on the cover or on the cover pages of every section of the report? You may not put visualizations such as these ones because they look, very traditional, very classic. They are great, but they are not that eye-catching. What do you put on the cover? You put something like that, because that is also a visualization that has a completely different purpose, not letting people compare things or see changes very accurately. Its purpose is to capture people's imagination, right? To bring people into the data. And then when they flip the page, when they pass the cover and get inside the report, then they get the traditional data visualizations. So both artistic visualizations and more analytical, more traditional data visualizations, the one that I tend to favor, have their place in the work of any visualization designer or any visualization or data team, I think. Anyway, so this is the end of the presentation. Before we get to that, I would like to explain first why all this matters. Well, it matters, I think, because the purpose of visualization, everything that I have explained matters, because the purpose of the visualization is not visualization per se. The purpose of visualization is to try to help people make sense of things. And in order to help people make sense of things, we need to first bring them into the information. That's why a little bit more creative visualizations may have a place in the world of data visualization. Then we need to help them understand through visualizations that make the information clearer. Now, where to go from here? The last part of the PDF that you are all going to receive contains links to many other resources. So first of all, I have included links to articles about visualizing uncertainty, which is something that could occupy 3 or 4 presentations. So I decided to include links to articles. I have a shared public Dropbox folder in which I am collecting every research paper that I find about uncertainty, how to display it, how to convey to people, how to visualize it, and so on and so forth. It contains tons of articles organized into folders from the most basic to the most advanced. I also have folders that contain articles and resources to keep learning about visualization. If this presentation got you excited, these are articles that you can use. And then books. There are many books out there. So first of all, free books, right? There are free books out there. For instance, Fundamentals of Data Visualization by Klaus Wilke is an excellent introduction to data visualization, and the draft of the book is publicly available online. That's the link to the book. And then if you like coding, right, R for data science is a great introduction to the world of the R programming language. And the first few chapters are about visualization. They are about visualization. Then there are books about, statistics, popular science books about statistics. I included them because I think, as it was mentioned at the very beginning of the presentation, I really care about democratizing all these skills and bring everybody up to speed with all these skills. So my own book is here, but there are others that are absolutely extraordinary. The Art of Statistics by David Spielharder, Counting by Deborah Stone. This is very recent. Naked Statistics, How Not to Be Wrong. Bad Science by Ben Goldacre, a medical doctor in the UK. There are so many nowadays. These are not books probably for you, because all of you probably are very familiar with the ideas contained in these books, but they're very, very helpful to everybody else. Some of them were very, very helpful for me, someone who doesn't have a formal background in statistics. And then books about fundamentals of data visualization. Storytelling with Data is a great introduction to that. Better Presentations by John Schwabish is a book that contains a section of visualization, but it goes beyond that and talks about how to make a better PowerPoint presentations. Books about exploratory visualization and the scientific side of data visualization. Visualization Analysis and Design by Tamara Mansner. Huge classic. Huge classic. Information Visualization Perception for Design by Colin Ware, another classic. Books about data analytics. Show Me the Numbers by Stephen Few. the big book of dashboards, and if you work with Excel or Power BI, I extremely recommend Georges Camoes's Data at Work, which is not a book about Excel per se. It's a book about principles of data visualization, but all the charts in the book were designed in Excel. When Georges showed me this book, I think that my reaction was, how did you design this as an Excel? This is not possible. Excel is so limited to design data visualizations. Well, if you want to be disabused of that idea, if you want to see what Excel is capable of, I would recommend that you take a look at that book, and also to George's website, excelcharts.com, in which he has several tutorials. And then books that are inspirational. I am a great believer in learning by copying other people. Copying not in the sense of plagiarizing, obviously, but in getting inspiration from other people. That's how I learned. I didn't learn only by reading, studying, designing. I also learned by looking up to, classic visualization designers and sort of like borrow ideas and styles and ways to do things from them. So these three books that you have here are books that are not intended to be read cover to cover. They are more intended to be browsed randomly in order to extract great ideas. And finally, books about cartography. Cartography is one of the most overlooked branches of data visualization. Many people who work in data visualization don't have a very good grasp of cartography. Well, cartography, map making is extremely important. So I will recommend that you take a look at least at one of these books, any of them, thematic cartography and visualization, the elements of cartography. Any of these will equip you with the basic skills that we all need to design better maps. And that's the end of the presentation today. I think that we only have 5 minutes until the formal end of the presentation, but I'm not in a rush to go. So if we want to extend this, for 10 minutes or even 15 minutes to answer a few questions, I'm completely up to it. The organizers can let me know. I'm not in a rush to leave.
Thank you, Alberto. We certainly will take a little bit of more of your time because we have some questions. But first of all, a big round of applause, silently, as in a
yes, silent applause. Thank you.
Maybe just a last comment about the physical visualization you showed with the coffee cup, because I think you also follow or is following the path of Hans Rusling, because Hans Rusling was presenting the world and the demography with boxes. So this is also a video to show, boxes and show how
I've seen people visualizing data with Lego pieces, for instance, and people can touch them. This, by the way, is there are other ways to communicate data, not only data visualization. There's also data sonification, which is a field that has existed for many, many years. We can transform data into sounds. There is also data physicalization, right? We transform data into objects of different sizes, different shapes, so people can touch them and feel them, right? So we can take advantage of many other senses. But yeah, Rusling was great. That presentation in which he used blocks to see how the population of the world changed, that was a great presentation.
Yeah, I think for educating young people, for example, to data, it could be interesting. We have some questions from the audience. Joe, sorry, I'm not used to pronounce the Portuguese name. Said, and I will reformulate this question, that in a crime data line, it may be that the line itself has been influenced over time by these outliers. So what could be the line, but it's
could be. Yeah, that's a very good point. It could be that those outliers have always existed, or perhaps the outliers have changed. Some places have become much less violent, and perhaps there's huge variation throughout time. I don't know. But the point still stands. If you have that, if that is a feature of your data, that there is huge variation and huge extreme values over time, etc., you better explain that. You better explain that to read. It's not the last point on the line. It may be another in past points of the lines. People, in order to understand that message better, cannot just be shown the national rate. They need more detail, because otherwise they will not be able to interpret the data correctly. I know that. I mean, that chart misled me. I only became aware of this feature, this glitch in the data. It's not really a glitch. I mean, it's a feature of the data. There is like huge range and skewed distribution when it was explained to me by crime statisticians. Well, there was a story in the New York Times that discussed the problem with that chart, and there were several statisticians who work with crime statistics saying, yes, there has been an uptick, but it's largely due to, these extreme values. So those need to be explained.
So in fact, in this graphic, there are no annotation layer actually. So it probably highlights one of your points that this graphic should have much more explanation than what you have.
Much more explanation. Yep. Mm-hmm. Yeah. Much more explanation. The explanation. All right. So the point that I usually make is that the amount of explanation that you provide in a visualization is dependent on the type of audience that you're talking to, right? Many graphics out there, one of the examples that I have in Hotshot slide, as you know, is the map of hurricanes in Miami, right? But in Florida. The National Hurricane Center in the US publishes a map called the Cone of Uncertainty, in which they show the probable paths of storms, right? And many people misinterpret that map. Many people who see that map at first, they don't interpret the cone as a set of possible positions of a storm in the next 5 days. It's a cone that represents the growing uncertainty in the predictions. They interpret the cone as an area under threat, right? If I am inside the cone, I am in danger. If I am outside of the cone, I am not in danger. I describe this in a lot of detail in the book. I also wrote for the New York Times about how people misinterpret this map. But the point that I made is that the map itself, there's nothing wrong with it, because originally that graphic was not designed to be consumed by the public. It was designed to be consumed by experts, by people who know a lot about that data. So if you're a statistician, let's say you work with demographics, and then you're presenting your data to other demographers or statisticians who work with demographic data, there's not a lot of explanation that you need to include in your visualizations, because you can assume that there is the same level of base knowledge, right? But the graphic that you present to your peers and to your friends will become different if you present your information to the general public, to someone like me, who may misinterpret that graphic if you don't explain it to me, if you don't add that clarification, that annotation, if you don't show a little bit of detail, if you don't discuss the glitches or possible features in the data. That is an intrinsic part of visualization design, taking the possible audience into account.
Yeah, and in this case, as in any others, and also it was the case in the crime, the uncertainty, how to visualize uncertainty, you emphasize
how to visualize uncertainty.
Mm-hmm. And some people do not understand that.
Yeah.
So you have a trade-off between providing the right information, but maybe not to an audience that is prepared.
The challenge with uncertainty, by the way, is that most people cannot interpret uncertainty correctly, right? Actually, one of the pushbacks that I usually get from general readers when uncertainty is presented is that audiences tend to become nihilistic, right? In the sense that we present a lot of uncertainty, so we disclose what science really is. Science is uncertain, right? It is uncertain, but at the same time, we also have confidence. So there's a balance between uncertainty and confidence, right? We are reasonably confident that this is the right point estimate with this level of uncertainty. So it's not just about communicating uncertainty, it's about communicating and explaining the interplay between all those factors, right? Related to probability, obviously. How to do it correctly, that's still a question that needs to be answered. Again, it may depend on the case that we're talking about, but it is essential to work in these areas, because in many cases, showing that level of uncertainty is absolutely essential. It's part of the information that needs to be presented. But many journalists, communicators in general, refrain from showing the uncertainty precisely because of that, because they fear that by showing the uncertainty, the reaction of many readers will say, well, scientists know nothing, or pollsters know nothing. Well, we do know something, but probabilistically, right? It's not deterministic and super precise. It's just a range of possible values that this variable could adopt, and that's sort of like the uncertainty. The question is how to explain all that using language that normal, quotation marks in there, normal people can understand. Because if we use the language from statistics, like we use terms such as error, when we use the word error, a scientist hears something, but a normal, quotation marks, person hears another thing. An error in common language is a mistake, right? Which has a completely different meaning. And there are many words like that, right? So jargon and scientific language is also quite risky. And again, we need to find ways to translate all this knowledge in a way that people can. That's why I'm so interested in books that try to popularize all these ideas, because I think that we can use them as examples of how to translate all these, because those books, by the way, and I have proof of these, popular science books about numbers and mathematical thinking and statistics are gateways towards deeper understanding or towards deeper studying. I have witnessed several people who started reading, let's say, The Art of Statistics, and they got so interested that they started reading actual books about statistics, like learning statistics. That's fantastic, because people fear statistics, right? They think that statistics sort of like sorcery or something like that, when in reality, it's something that can be studied. It's like visualization. I mean, it's hard. It takes a long time to understand it. It requires deep study. But if you are willing to put the effort, it can be learned. And when you learn it, like visualization, right, it opens the door, it opens your eyes to wonderful realities, to other ways to understanding information. Anyway, I could ramble about this for hours, and I don't want to do that because there are more questions.
Yeah, I think it's a really also a very interesting topic, and we could talk for hours on that. But I think, and it may be a little bit related. We have a question from Andre saying that, do you think it's okay to skew the graph, say to play with the scales to underline the conclusion you want to convey? I mean, it's a fine line between improve visualization and skewing the graph towards some partial conclusion.
There's a whole section about that in my latest book, because many people have, in that one. Although I recommend the yellow cover one, which is, I think that it looks nicer. I don't know. I like the yellow version better. Both of them are fine. So many people have tried to come up with, for example, rules to sort of like decide on the aspect ratio of a time series line graph. For instance, William Cleveland, a famous statistician who wrote 2 wonderful books about visualization, The Elements of Graphic Data, for example. So Cleveland proposed a rule called banking at 45 degrees. He said, in a time series line graph, the average angle of all the lines in the line graph should be 45. And that will achieve the perfect aspect ratio, banking at 45 degrees. Now, is that really a rule? I don't think that it is a rule. I mean, because it has not really been tested seriously in the lab. It's just a recommendation, a reasonable recommendation, but it might not be a perfect a sort of like rule of visualization design. So my own approach to designing scales, aspect ratios, etc., is sort of like, I mean, and I know that this is going to sound non-scientific, but many decisions in visualization are non-scientific. I simply try to feel whether it looks right. I try to take a look at the data. And then I ask my question, does this feel right? Right? Am I trying to visualize the data in the way that I understand it? So if you think that you need to exaggerate the aspect ratio a little bit in order to highlight a particular feature, as long as you don't scale it up dramatically in a way that it distorts the data, it is fine. And in some cases, as I explain in the book, for example, showing climate data, right? If you don't sort of like increase the scale and frame the scale in the right way, you may be downplaying the data, because some people have proposed, let's visualize the change in climate, in average temperatures using this scale, and they ended up showing graphics that varied very little, right? But the thing is that you need to look into the data. A variation that looks extremely tiny, 0.3 degrees, right? Or 0.5 or 1 degree, it sounds very small, but that's extremely significant. 1 more degree, that's a huge, huge change. It's the difference between a habitable world and a non-habitable world, essentially. Actually, the difference should be bigger, but I guess that you get my point. If the difference between 1 and 2 sound very little in the abstract, but it's so significant, so important when you understand what the data truly means, then you need to adapt the scale to that significance in the non-statistical sense of the word, obviously. You will need to exaggerate the axis of the y-axis of the line chart in order to make those variations visible to the eye of the reader, right? So the answer to that is that we need to look at the data and then feel what it feels right, and always try to convey. This is a principle that comes from the world of journalism. Ideally, journalism should consist of conveying to our readers our best understanding of what the truth is, our honest truthful, best understanding of what the truth is. It may not be the truth, but at least it's our best understanding, honest and truthful understanding of what the truth is. That's the same question that everybody needs to ask themselves whenever we design a visualization. Would this feel right to me if the visualization were presented to me? If it does feel right, it's probably right to do it that way.
Oh, thank you. I think very inspiring reflection on that. Mm-hmm. We have two questions that I will merge from Nuno and Ines about, from Alvaro and Ines about Tufte influence and also about the Tufte rule about the data-ink ratio. Mm-hmm. So it's funny because you just pronounced one of the rule of Tufte, the first one, show the data. Mm-hmm. Or look at the data.
Look at the data,
And here, so the question is, how are you influenced by these other designer?
Tufte is an essential figure in the history of data visualization. I still recommend, in particular, his first two books, the Visual Display of Quantitative Information. I think that is a classic in the field of data visualization. I think that is worth reading. The challenge with Tufte, though, is that he tends to present his ideas, as particularly in the first books, as if they were rules, like maximize the data ink ratio. Well, no, it depends. It depends on what your visualization is for. Obviously, yes, in a context of analytical visualization, statistical visualization, try to show as much data and try to include a small amount of decoration or whatever you want to call it, or bells and whistles, that works. That's great advice. But as I tried to explain before, I mean, that is not the only way that visualization can or should be used. Some graphics will need to look less precise. Some graphics will need to look fuzzier. Some graphics can be funny and make you smile, and that's perfectly fine if that is the purpose of the visualization. So all these ideas always depend. That's the reason why I prefer to talk about reasoning, not about rules. There are really no rules that are set in stone, because those rules are always dependent on the context in which we are visualizing our data. But yeah, he was a great influence. Many of those ideas, by the way, don't belong to Tufte. I mean, that's something that I must say. So Tufte was greatly influenced by Tukey, for example, by William Cleveland. Actually, I would actually recommend to read The Elements of Graphing Data before I recommend to read The Visual Display of Quantitative Information. Both books by Cleveland, The Elements of Graphing Data and then Visualizing Data, that pair of books, they're great. They extend on the work of John Tukey in terms of exploratory visualization. And another thing, they are much more practical, which is another thing that I feel sometimes with Tufte's books that are a little bit more sort of like philosophical. And that's great. I love reading philosophy. That's why I still recommend them. But if you want something that is a little bit more hands-on and applicable to your work, there are other books that I tend to prefer.
Okay, we will finish with two more questions that I will group together, I think, also from Gabriel and Marta. Do you think that data visualization is so important in a time where there are so many fake news? Is it always better to turn to primary sources and you know, all these sites with fact checking should be really important in what Gabriel says? I think it's more common than question. And Marta said, what about the treatment of the COVID-19? We have seen so many graphics. You mentioned that people should be interested in statistics, and I think with COVID-19, many people are playing with numbers and trying to extrapolate what it means for them. So I think these two questions are some sort of say, what about the primary sources and COVID-19?
So one more related to misinformation, false news, and something like that in relation to visualization. Second one about COVID-19. Let me begin with the COVID-19 one. I think that in most cases, the work of news media, at least in the countries that I'm familiar with, which are the United States, Spain, and Brazil, has been in general as good as it could be. In general, there may be exceptions to this, but in general, what I have observed is an effort on the part of journalists to try to convey the limited and highly uncertain data that we had at hand in the best way that it was possible. So also the UK, the Financial Times, I think that they did a great job. The New York Times, the Washington Post. Obviously, again, they were dealing with a situation that was sort of like evolving in real time. So that required a lot of corrections and those corrections were made. So in general, I am quite happy with the results with what I saw in news media. There were obviously mistakes, but those mistakes were corrected, they were amended. So in general, yes, I'm pretty happy with that. On the other hand, and this connects to the other question, misinformation, visualization is like writing or like speaking. It can be good, it can be used for good, or it can be used for ill. So we have also witnessed many people misusing data visualization and misusing data to mislead the public. For example, at the beginning of the pandemic, I saw several absurd bar graphs comparing the mortality of COVID-19 to the mortality of car crashes. So, well, again, I'm not a statistician, but I would never compare a phenomenon that has very little variation year by year, like car accidents, with a disease, just simply because car crashes are not contagious. And diseases are contagious. So there is the opportunity, or there's obviously what would happen is that one of these phenomena changes, so to speak, arithmetically, right? Little every year, but the other one can increase exponentially, right? In terms of spread. And we don't even know what the mortality of COVID-19 is really at the beginning of the pandemic in the first place. So that was another discussion. And that bar graph was completely absurd, not in terms of like the design itself, the design was fine, but the ideas that those graphs embodied were completely wrong. And in some cases, they were probably designed to deceive the public. The challenge that we face nowadays is that we are dealing with an environment in which good actors, people who do their best to tell the truth, and that includes you all, right? You all belong to institutions that are supposed to be truth-telling institutions, right? You try to provide, again, your best understanding of what the truth is. You may be mistaken. That's perfectly fine. Everybody can make mistakes as long as we correct them visibly, right? But you try to convey your best understanding of the truth. Ideally, that should also be a goal shared by journalists, by scientists of all kinds, by the Centers for Disease Control and Prevention in the United States. All these are, populated by people who try to tell the truth. I call them truth-telling institutions, right? They make mistakes like everybody else, but they try to correct them. The problem is that nowadays we live in an environment in which truth-telling professionals can have the same visibility and the same tools for communication as bad actors, people who try to mislead other people for political gain, to push an agenda, and so on and so forth. And that's a huge challenge. I think actually that is the challenge of our times, because I think that many of the phenomena that we're seeing nowadays, the wave of extreme right-wing populism in many countries, the United States, Brazil, and some countries in Europe, is closely related to this communication environment. Now, how to deal with it? Well, visualization, can play a role, but it's like anything else. It's like writing or speaking. It can be used for good or for ill. So the answer is not the visualization, right? I don't know what the answer would be. Perhaps we need more people pushing back against those trends, critiquing and criticizing those phenomena, to raise our voices a little bit more, to try to talk to people more in order to sort of like tell the truth more. But that may not be enough. And other measures may need to be taken. I don't know. I have no expertise in that area. Though.
Thank you very much, Alberto. I think we have to finish this Q&A session because the other presenter, that is me.
Oh yeah,
the rest.
Good luck. Yeah.
So I'm sorry for the people for the question we couldn't handle during this moment. I want also to mention the fact that this session was recorded and that we will send the link to your PDF and to your website after the workshop. I wanted to finish this by saying that in this book, your latest book, at the beginning, there is a quote by Rusling saying, from this book, I think, saying, the world cannot be understood without numbers, and it cannot be understood with numbers alone.
One of my favorite quotes, yeah.
If you allow me, I will finish this very nice session, and by thanking you, of course, and by changing a little bit this sentence and saying that the world cannot be understood with Alberto Cairo alone, but it cannot be understood without Alberto Cairo.
You are too kind. You are too kind. Thank you very much.
Thank you very much, Alberto. So we are doing a short break of a quarter. We come back at 4 in Portuguese time. Thank you again so much. Virtual applause.
Take care, everyone, and thanks again for having me. It was a pleasure. Bye-bye.
Thank you very much, Alberto. Bye-bye.